This is the microphone I use. If I remember right, it was around $50, so it's not an expensive mic, but I've been very happy with it. I did finally get an arm to mount it on, and that really helped with the positioning of it. What it didn't help with was the isolation of the microphone from the vibrations of the floor and desk. So I wanted to get a shock mount for it, but one that could be used with a better microphone in the future. The arm I got was a Rode, and I was pretty pleased with the quality of it, so I was looking at their SM6 shock mount. I do find it a bit strange that none of the specifications for any of the items list the mounting threads. But I have the microphone in hand, so I can measure the threads on it. I would expect it to be metric. That's probably a 22mm thread, and it has quite a fine thread pitch. I don't have a metric thread gauge, but I do have an M6x1 screw, and that seems to be a perfect fit. Yeah, it's a 1mm thread pitch, so maybe that is a standard microphone thread. I think an XLR connector could fit through that opening. So I ordered the SM6. It's quite a bit heavier than I expected. Again, seems very nicely built, and comes with a pop filter, and I could sure use that. Now this I didn't expect. Of course I was hoping M22x1 was a standard microphone thread, but I guess that was just a bit naive of me. The thread size in the SM6 being smaller than 22mm, that is a big surprise. If anything, I was expecting a larger thread size for the SM6. Rode's main microphone is larger than the one I have and uses an XLR connector. Maybe I'm misremembering the size of an XLR connector. I was thinking they were about 3/4 of an inch in diameter. So the ID of this, let's say, nut is a bit over 19mm and looks to be a fine thread pitch. Okay, the 1mm pitch screw seems to fit the thread perfectly. I'm going to guess it's an M20x1 thread. I could return it, but I have the tools to make myself an adapter. Don't know if I have the skill, but I really think the shock mount and pop filter will help a lot. So it's time to hit the lathe. Before I get to the lathe, have to do a bit of preparing. I have some 1.5-inch diameter aluminum rod, so I'm going to use that to make the adapter. Looks like I'll need a little over 1.25 inches of length. I'll cut me a piece off a little bit longer, just to make it easier to mount in the lathe. I'm going to start with the internal thread section. I'm sure that will be the most difficult for me. I've not done much internal threading at all. I'm using the 4-jaw chuck for this. The 3-jaw has problems with anything over about 1.25 inches. So I'll have to center this in the chuck. I'll get it pretty close to center. It's rough stock, so it's not going to be perfectly round. I will flatten the end off. Old bandsaw from Harbor Freight still cuts a pretty square end on a piece of metal, but I want it to be smooth, flat, and square. So this is the part that will screw onto the microphone. The OD of this I want to be a bit under 27mm. I'll go a bit light on the cuts till I get the shoulder depth I want, shooting for about 0.52 inches. Neither the OD or the depth of the shoulder here are critical. I'm right at 27mm, but I do want to be under 27. So I'll take a couple of light passes, see if I can get a nice finish on it. Though I'll be clamping to this section later on, so I don't guess it needs to be too nice of a finish. Now the serious stuff begins. I'll start with a center pilot hole. Then I'll drill through the entire piece with a 1/4-inch drill bit. It's a small motor on this thing, so I'll have to go a little bit at a time. Then it's a letter T drill bit. Diameter is a bit over 0.35 inches, so it's going to remove a bit of aluminum. Next is a 7/16 inch drill bit. And finally a 1/2 inch drill bit. That will give me enough clearance for the boring bar. I need about a 21mm ID for this, but I want to limit how deep the 21mm section is. I'm going to go about 0.82 inches in. That should give me at least 0.1 inches of distance before I get to the 20mm external threaded section. Hopefully a couple of last cleanup passes will do the job. 20.99 or so, that's as close as I need to be. With these calipers, I would expect the hole to be a bit larger than 21 millimeters, which should be just fine. I will chamfer the inside edge, hopefully give a nice smooth lead in for the threads. I'll chamfer the outside, don't want to have a sharp edge there, and it makes it look better. Now to set up for the internal threading. I've got the protractor set to about 29.5 degrees. I'll square the tool holder up to the face of the part, one reason for making sure the end of the stock was flat and square. I'm going to set the threading point at the edge of the workpiece, and I will set that as the 0 position. The boring bar leaves close to a flat bottom, which the end of the threading bar will bump into. So I'm going to use the threading tool to give a bit of a taper to the end of the 21 millimeter section. I've never threaded into a blind hole before, so I want to have plenty of space to stop the threading before the tool crashes into the end of the 21 millimeter section. So I'm going to undercut a section from about 0.55 inches to 0.8 inches. I'm going to go at least 0.7 millimeters deep. That should be plenty. First, I'm going to try and get all the chips off of the lead screw. Even though it's just thin chips of aluminum, it can't be good for the lead screw or the half nut. I've got the compound and cross slide dials set to 0 here, so this should be the scratch pass. So even with almost no load on it, it stopped well before I ran out of room, so should be good to go with even a bit more speed. I'll move the tool away from the part with the cross slide and back out of the part. For the first couple of passes, I'll move the compound in 5/1000 of an inch. I'll reduce the depth of cut after that. Here I have reached 25 thousandths on the compound. If I've done the math right, that should give me a depth of cut of 0.55 millimeters. From looking at a thread chart, I'm not sure if I need a depth of 0.54 millimeters or 0.61 millimeters. Or maybe neither. I'm not sure about the nut part of threading. I'll do some spring passes until it doesn't really cut much. Took 3 spring passes to do it. So now I'm ready to see if it fits. Try and get as much of the cutting oil off my hands as I can. Hate to smudge up my microphone. Well, that seems to thread right on. Okay, that works great. It's a little tighter thread than the base that came with the microphone, but that base is a really loose-fitting thread. I think that's perfect. Glad I didn't go any deeper. Makes me think the 0.54 millimeter thread depth is the right value. I think the hardest part is complete. Of course, the threads have some very sharp edges to them, so I'll take some fine sandpaper and just knock the edge off them. The spacer section just needs a nice finish on it. And this is the surface I will reference to get it back in the right position when I turn it around in the chuck. I'll also put a little chamfer on it to make it look nice. Okay, looks like it's within 0.02 of an inch of being on center. That should be plenty close enough for this. I'll mark myself some rough locations. I made the piece a bit long so I would have plenty of space to hold it in the chuck. Guess I overdid a bit. Have over 1/10 of an inch to remove. Okay, I have the length I need. This is the section that will get the 20 millimeter external threads. A lot of aluminum to remove here. The OD here is just under 20 millimeters. I'm going to undercut for the end of the thread here. I'm only going to go in a bit over 0.5 millimeters, should be about the same as the thread depth. I want about 5 millimeters of thread. The rest I'm going to undercut. Will give me a bit more room to stop the lathe. Again, I have the protractor set to about 29.5 degrees, only now swinging the compound counterclockwise from the 0 position. Well, 0 position to the cross slide, 90 degrees by the scale on the lathe. That little difference really caused me some trouble first time I tried threading. I forgot what instructions I was following, but there wasn't but a couple of pictures, one of which was the nice finished pretty threads. Said set the compound to 29 degrees, so I did using the scale on the lathe. I think it was about the third try I realized something just isn't right here. I'm doing something completely wrong. My threads look horrible, more like a sawtooth. Don't even remember now if it was a video or a picture of a proper compound position I saw. Oh wait, that's not the position my compound is in. So after a bit more research, I found out the 0 position is in line with the cross slide. And thinking about it, I thought that makes perfect sense. My threading has been much better since correcting that error. I will chamfer the outside for a smooth thread entry. Again, I'll take the first couple of passes moving in the compound by 0.005 of an inch, and then drop the cut depth back as I progress. I think I'm at a thread depth here of about 0.49 millimeters. Compound dial is at 22 thousandths, and it won't even start to thread on, so maybe not as deep as I think. Compound set to a bit over 24 thousandths, so thread depth somewhere between 0.53 and 0.54 millimeters. And it fits. It's a very tight fit. So I'll make a spring pass, sand the burrs off of the threads, and that should do it. Still a very low clearance fit, but there is so few threads here, I think I'm going to leave it at that. Threads on and off just fine. Now I need a bit over 15 millimeters of opening for the USB connector. So I'm going to shoot for a 16¼ to 16½ millimeter bore diameter. Smallest outside dimension is about 19.3 millimeters, so that will still leave me with plenty of aluminum to hold things together. I'm at a bit over 16.3 millimeters, so just making a very light smoothing pass. I'll chamfer the inside edge. Make sure I don't have any sharp edges. I don't want the USB connector catching on anything. Then chamfer the base part of the spacer, just to do away with the edge and make it look nice. I'll take a scuff pad and kinda give the spacer section a brush finished look. This will be the only part of it that will be seen. I guess I should look into how to do some at-home anodizing. Would be nice to have it match the black of the microphone and shock mount. Clean it up good, get all the cutting oil and filings off of it, and I think I'm good to go. That is definitely a great fit on the microphone. Couldn't have done better if I had tried. A tight thread fit on the shock mount. I guess I should have maybe gone in another 0.5 thousandths on the compound on this one, but still no trouble starting the thread. There's just almost no play in it. It's not like it's got to be threaded and unthreaded a lot. Can't see it being removed till I try a new microphone, and that probably won't happen for some time. I'm happy with my adapter, and reinforces why I consider the mini-lathe one of the best tools I've ever bought. I looked at them for a couple years before I bought one, really thinking, would it be one of those tools I buy and then sets around never being used? While it may not get used as much as a drill press, it's pretty close. Definitely one of my favorite tools. Thank you for watching.